Hello, my name is Sophie. I am a maths tutor and founder of Tutor in a Box, and I am doing this video today to talk to you guys about shapes, okay, and areas and all those little formula bits you need to know. So, for your GCSE exam, there are a couple of key formula that you really need to know. So you need to know how to work out the area of a square, the perimeter of a square, the area of a triangle, and the area of a trapezium. Now, initially, you might think, okay, that's not too bad, or, oh, I kind of know how to do that, but you need to make sure you can absolutely nail it. And I know that every single one of you can learn these formulas. And once you've learned them, they can help you answer questions that might be inaccessible otherwise. So they're really useful to know. Before we go on to it, I'm just going to share my screen with you. And I am going to write all the formulas up. So hopefully you can see my white blank whiteboard in front of you. And so the formulas we are going to go through today is the area, and I'll write that, the area of a square, the area of a triangle, triangle, and the area of a trapezium, the area of a circle, and we'll touch actually on the area of a parallelogram. Now you'll notice that I focused a little bit on area here. We will touch though on perimeter of a square and the circumference of a circle, so we'll come on to that. But first things first, let's look at the area of a square, okay? So the formula for this is base times height or length times height, okay? So that means if I have a square that looks a little bit like this, one length is 3 and the other is 4, then I would just do 3 times 4, which equals 12. So my area of that square would be 12, okay? So nice and easy, we do one length times the other lengths. It's the same if it's a rectangle. Now, if it's a square, the length should actually be the same. But if it's a rectangle, this length along here might be 7 rather than 3. And so you just do 7 times 4. But the process of it is exactly the same. Okay, so that's the area of the square. One side times the other side. Now, let's look at this, the area of a parallelogram. And this has confused some of my students recently. So if we draw a parallelogram, it looks a little bit like this, okay? So it is just a rectangle, but on its side. So think of it as a wonky rectangle, slightly falling over, maybe had one too many drinks, but it's just on its side and it's just lopsided. Its properties are very similar to if it were a rectangle. So this length and this length are parallel, and they're the same usually, and this length and this length are parallel, the lines are parallel, and the length is the same. So if we have 7, let's say, and 12 along here, again, to work out the area of the parallelogram, we would do base times height. And in this case, that would be 7 times 12. Okay? And that would give us the area of my parallelogram. So it's the same as if I was working out my area of a square or rectangle, same formula, so don't be thrown by it. We haven't actually put the answer here. Obviously answer that. So then the area of a triangle, this is the next one we're going to look at, and this is half of my base times height. Okay, so it's the same formula we've been using so far for a square and a parallelogram, but we're just halving it. Easy peasy lemon squeezy. And the reason for this is because if we look at a square, if we take the example we've had at the beginning and we cut that in half, that's now a triangle. So we do exactly the same thing as we did earlier, base times height, but we just halve it. So if I've got a triangle that looks like this, and I said that's 3 and that's 7, and I want to work out the area of this, we just do a half times 3 times 7. Now 7 times 3 is 21. Half 21 is 10.5. So my answer for the area is 10.5. Easy peasy lemon squeezy. Okay, so my square and parallelogram are the same. My triangle is almost the same. We've just got that half at the beginning. Okay. So on to area of trapezium. Okay. So trapezium are these funny looking things that look a little bit like that. But I'm going to redraw that because that was a bit squiggly. But the idea is we have two parallel lines. So we have a parallel line on top and on the bottom. And these are running parallel to each other like this. We then have two lines that are going in, okay? So these lines are not parallel, okay? This is really important. These lines here and here are not parallel. So we'll have a height or length here and another length, let's say here. And then we might have a height up here. Let's say this height is 5, okay? And the formula for a trapezium, I'm going to write it right at the top here, is a half of the top height plus the bottom height times by the height, okay? So half of the top length plus the bottom length times by the height. So for example, here for that area of trapezium, we're going to be doing a half of that top length, which is 2 along here, plus that bottom length, which is 4, times my height. They might sometimes call this my vertical height or the length of my height in between or whatever it is, but that just basically means how tall it is. So that then gives us 1.5, sorry, that then gives us 3 times 5, which is 15. Because 2 plus 4 is 6, a half of 6 is 3, and 3 times 5 gives us 15. So the area of this is 15. The key thing when we're working for a trapezium is we work out the average length of the two sides. So the two sides are parallel. So if I show you in a different color, let's use orange. The side along here, the very top side and the very bottom sides, these two are different lengths, and that's really, really important. And so that's where this middle bit comes in. We're working out the average of those two lengths. So we add the top and the bottom and divide it by 2 to give us that average. And if they're easy numbers, we can also look at them and say, well, what's the average? What's the middle point? So we could probably look at 2 and 4 and say, well, halfway between 4 along here is 3. So 3 times 5. But if you get more complex numbers, that's why we add them together and divide by 2. But you can look at these two numbers, 2 and the 4, and say what's halfway between them and just times them by the height if that's easier. Okay, so we've covered quite a bit so far. We've looked at square, parallelogram, triangle, and trapezium. And finally, we're going to look at the circle. So the area of a circle. Now, I'm not going to try and draw a circle freehand. I'm going to use a wonderful computer, to show you this. So that's a pretty round circle I'm going for. And we have a little dot in the center. Now, when we're looking at circles, it's important to note one thing. So I'll change the color of the pen so you can see the circle. So a little dot in the center, and it's really important to learn that is our radius, okay? So if we're coming from the middle of the center, middle of the circle, to the edge of the circle, it's called the radius, okay? So R is just my radius. And this is just some number which tells us how long it is from the center to the edge. Now, if I was to go all the way along, so if I was to go from one end all the way to the other end, that now becomes D. And D stands for diameter. Okay, so trying to write this freehand and keep it as neat as possible. So hopefully you can still read it. So D is my diameter. So my radius is half of the whole length, and my diameter is the whole length. So you'll see that actually sometimes we write D is equal to 2R. So all that means there is my diameter, which is my whole length, is just equal to 2 lots of my radius, because that's 1 lot of my radius and that's another lot of my radius. So 2 lots of radius equals my diameter. Okay, so then back to the area of a circle. My area of a circle is pi r squared. Okay, so the area of a circle is pi r squared, and pi is approximately 3.14. So if you're asked to estimate and use pi, your rough estimate will use 3 or 3.14, and then the radius, which they may tell you. So they may tell you the radius is 5 centimeters, for example. You'd then pop that in. So if we had an example here, and my radius is 5, to work out the area, I would do pi times 5 squared. So then that would be pi times 25. Now, if I'm estimating that, and it's in a non-calculated paper, I could use pi at approximately 3 and say 3 times 25 is 75. So that would be my approximate. Or if it's in a calculator test, you will get out your calculator and you will press the pi button. So for anybody who doesn't know where their pi button is, if you press shift and then it's that one under the answer key, sorry, one under the times 10 key that looks like that. So it's that pi sign. So then if you do pi times 25, you will get 78.53, okay? Whoops. 78.53. And that is then your answer, okay? So we've covered quite a bit here already. So just to recap what we've done so far, we have covered the area of a square. Excuse me, coughing away. We've covered the area of a square. We've covered the area of a parallelogram. We've covered the area of a triangle. We've covered the area of a trapezium. We've covered the area of a circle. So what I want you to do now is pause this video, and I want you to write down on a blank screen here the area of a triangle, the area of a square, the area of a trapezium, and the area of a parallelogram. Okay, hopefully you have managed to pause that and write them all down. We're now going to work through a couple of questions. So, the first question is this: find the area of the trapezium. Okay, so find the area of this trapezium. And what I'm going to suggest is that you pause the video and you have a go at this yourself. Once you've had a go, then unpause it and do watch the solution through. So, first thing we're going to write down is the area of a trapezium is a half A plus B, and just remember A and my B are my lengths, times by my height. So we've got the average of my top and my bottom times by my height. So we've got a half of 8 plus 10 times my height, which is 3. Now, if you'd have looked at the numbers, you may well have managed to work out that actually the average of my length, so the average of my top length and my bottom length is 9, because 8 and 9 is halfway between 8 and 10. So we end up with 9 times 3, which gives us 27. So our area is 27 centimeters squared, meters squared, whatever unit they have given you in the exam. So let's pretend it was meters they gave us. Our answer would be 27 meters squared, because it's an area. Hopefully you got that as well. Let's do one more question for you. Okay, we will draw a very rough circle. No, we won't. Let's pop a little circle here like this. Okay, fabulous. So I'm going to tell you, oops, that's still on drawing mode. So I'm going to tell you that the diameter of this circle is 10. And I want you to find the area of this circle. So then the first thing we do, working this out, we'd pop down and we'd write the area for a circle. So the area for a circle is pi r squared. And remember, and we'll just put a little a there for area. So pi stays the same. Now remember, our r stood for radius, and that was halfway from the middle to one side. So my diameter is all the way along. So to get my radius, I've got to halve it. So half of my diameter, so half of 10 is 5. So we do pi times 5 squared. And then if it's a non-calculator test, you can pop that straight on the calculator, and you end up with the same numbers actually, I think, on the example on the previous page, 78.539 recurring, ... And so that gives you a little bit of an example of how to work out. There are loads and loads of questions on areas, perimeters, all those types of things. And we'll come and look at perimeters a little bit more in detail in another video. But for the moment, that's given you a really good start. Please learn the formula. They're really important, really key, and learn how to work them through. As always, any questions, do give me a shout. Otherwise, have a lovely day, and I hope you've enjoyed watching. Bye.